Small opening remarks as well. So good morning, BSides Liverpool. This is the first BSides Liverpool. I'm really excited. So first thing, I want to have one more round of applause to all the organizers. They've really worked hard. I've been in contact with them for like 6 months. So good work, everybody. These type of conferences and gatherings are a real game changer. Being chosen to open the conference is great honor and responsibility. Everything is fresh and new, but also fragile, like a seed just starting to grow. A seed of hacking wisdom and knowledge sharing. How the event will go today will probably go for a long time, creating a new tradition in Liverpool. Of course, there are bigger events like Black Hat, InfoSec, and DEF CON. So why do we need BSides? Why do we need BSides in Liverpool? BSides conference makes the true difference between the InfoSec industry and the hacking community. It's not about commercial businesses, it's about sharing experience and knowledge and meeting other hackers. There's a slippery path between being an industry and being a community. The difference is what you, the audience, the sponsors, us, the speakers, and the organizers will make of it. So go on, have fun, laugh, drink, meet new people, generate new ideas and projects. I'll be doing the same with you, probably drinking. So let's get started. The presentation I'm going to show today is called Focus on Your Malware, Not Infrastructure. I did a little survey on Twitter amongst my friends, researchers, other members of the security research community, and I asked them what is the thing the most challenging for them when they are developing and building their security research app. By far, also on the threads and in the survey itself, it was time constraints. Everything takes time, we don't have that time, and we actually want to go home a bit earlier, not at 1 a.m. every night. So this talk is about helping solving that time constraints. Basically, the way it was, the agenda is we're going to first look at how we currently build some modern research apps. We're going to look at introduction to serverless, what it is not, what is it good at, and what is it bad at, and some of the security considerations, because we are a security conference, we must look at that as well. We're going to look at some current projects, some of the latest things. We're going to look how they were developed and how we can use them to our advantage. We're going to have a hands-on example, slide by slide, showing how we can build something that used to be really hard for every security research, and now we can build it really fast and easy using serverless. And last, for the demo guy to go right, we're going to have a quick live demonstration how we're going to build a live app using serverless. Hopefully the internet and everything is going to work. Alright, so quick introduction to myself. I'm Segev Moyal. I'm an entrepreneur, researcher doing exploits, APTs, also a community advocate and a big football fan of Maccabi Haifa, if you know it, in Israel. Actually played against Liverpool once and won. Alright. Weird. Yeah. Alright, so I'm doing a lot of research. I'm also an entrepreneur, and there are some ways that almost everybody that goes to build a research app goes through. So let's assume we have some kind of a POC code I want to run. There's some POC that I want to deploy. First thing, I really need to start planning. I need to plan for the magnitude, what's the size, how many malwares I'm going to scan, how many URLs I'm going to work with. I need to budget. I need to understand what is going to be the volume of my work. I'm going to understand the volume of the network, all the bandwidth, all of those. And I need to start back usually for some resources from the company or sponsors or anything like that. So that takes a lot of time, and it's something nobody really likes to do. Nobody likes to, beg for budget or works on those kind of things. And let's say I got my budget, I got everything sorted, maybe I cut off some stuff, and then I need to start build up the infrastructure. Let's say I want to analyze some malware, I want to build a sandbox. So I need to allocate, I don't know how many VMs I can. I need to start build up the network to make it secure and private. I need to focus a lot of time on that. I didn't even start with my project. And then I need to find a way to start deploying my code. Let's say I'm using some continuous integration or GitHub or just simply on my machine, but still, only now I started to run my app. And once I started to run my app, then I need to start monitoring it, because we work with research app. Usually researchers are not the best developers. I know I'm not. And they break. And I start monitoring them. I can't stress how many times I've worked through the entire day, late into the hours of the night, And then, okay, I thought that my app is working, went to sleep only to wake up that it broke the minute after. So I have no research data, I have nothing to work with. And that's really, really frustrating. So I started looking and said, all right, I'm wasting a lot of time. I need to start thinking of what I can do better. But before I can understand what I can do better, I need to start understanding what are the main flaws of what I'm doing. I can start matching them. So the first thing of the, I guess, major flaws in research app development is the fact that I understood that it's not scalable at all. Makes it really hard. Let's say I'm working with some malware strain. Let's say Emotet is a good example. Emotet is pretty good at the way they distribute their attacks. One time they distribute 2 or 3 malware. 2 weeks after, 1 million malware on the same day. And then they're going quiet for a month, and then 3 malware, and then 2 days later, 1 million samples. So it was really hard to get up the infrastructure ready to sustain all of those malware and analyze them, and then just wait there with the infrastructure, just waiting for it to work. So it was something that was really, really hard. I needed to find a way to make my app scalable. The next thing I discovered is that we were not agile at all, which is not good. I mean, developers always focus on agile, on security research, not so much. And basically, let's give an example. Anyone here work with Cuckoo Sandbox, for example? Viper, any one of those tools? Yeah, I see some faces. So if you really want to get Cuckoo in production, it's a great app, but it takes a lot of time. You need like a team of DevOps and everybody to actually start working with it. And then as soon something breaks, because the app was worked as a full multi-purpose app, it has domain analyzers, document analyzers, file analyzers, working with VM databases. Then if something breaks, the entire app breaks. And more than that, if you want to do some code changes, then you need to take down everything, take down almost all the servers, deploy your code, run it, never works the first time, so you need to redeploy. Takes almost a day to actually in production to get it to work, and that also means that usually by quarters you actually deploy your code. So for research, a quarter, a few days, that doesn't work because you need to work really fast. So this is another example. And last, because all of those reasons, it means that we are really slow on adoption. If there's a new malware strain, if there's a new exploit, there's a new type of vulnerability, it takes us a long time to actually respond to it, which is horrible in these days. That people speaking about minutes now and not even hours, etc. So it's something we really need to focus on. So I worked with my colleagues, worked with friends, worked with the community, did some thread, did some analysis, and I came across a few ideas how to make it better. The first one was working with Docker, Swarm, Kubernetes, orchestration. Anyone familiar with it? Cool. So people familiar with it, it's good. It's actually much better than what it used to be. But let's take a Cuckoo example again. To actually get a proper Cuckoo running in Kubernetes, I need an instance for my database, 2. I need one for the web server. I need one for the processing. I need one for the ELK. I need one. It's hard. I'm a researcher. I'm not a DevOps. I don't want to spend all this time on running those apps. So it was really, really problematic for me. It wasn't enough. I was really tired of dealing with all the orchestration and servers and everything. And then I came across a really cool idea. It was relatively new. It's called serverless. I know it's a funny word. It's kind of an annoying word, but it's actually kind of what it is. Basically, serverless, it's the latest, brandest way for the cloud providers to make more money. And basically, that's what they do. They are like a casino. The house always wins. But it's actually cool. Some of them do it right. Basically, what it means, they've went into such a good stage of optimization that if someone ran some kind of a VPS or an instance, so some kind of resources and doesn't use it, they are gonna use it in a third-party kind of application in the serverless way. Basically, they're gonna use the scraps of whatever cloud resources that are left in their huge domain, the hot dogs of cloud. But basically, there's so much of it left. So they can actually provide you with an almost limitless resources for mostly short periods of time or different kind of tasks. So it's actually pretty cool. Basically, most of it is working on the concept of FaaS. F-A-A-S. Function as a service. Pretty new concept. The main one, and we are going to focus on today, is Amazon Lambda. There are also Google Cloud Functions, IBM OpenWiz, and lately, don't use it, Microsoft Azure. Sorry. But anyway, it's focused mostly for developers on the fact that you should focus on your code. BSides, right? Fuck the infrastructure. Basically, work just on your code. It actually works, but there are some limitations. We'll go over them. It also means that we are going to focus on, remember that, single-purpose functions. We are used, if you're working with Docker, multi-purpose apps. Now we're going to change our mindset to single purpose functions. And basically what it means, there's some kind of an event triggers, API call, writing to a database, file activity, something like that. You will get an event, you will process it in your function, and then you can do whatever you want with it, some kind of an output, save to a database, trigger another function, things like that. But you don't work on how we used to have one purpose functions for apps for everything. It's also really good for bugging and everything like that. Not last thing, but another really important thing is you don't pay for ideal. Super important. If you rent cloud servers, you rent EC2s, you probably know that you're using, most don't use 70% of what they own for long term of what they use. Even if they use Docker and Kubernetes, it's actually pretty hard. With serverless, you basically only pay for exactly what you use. You do pay a bit of amount, but still, usually on the long term, it's much better. And the last thing is that it's very, very scalable. Let's go back to the Emotet example. I can analyze one malware strain if I do it statically, for example, and I can analyze 1 million. I don't need to wait for it. I don't pay for the time I'm waiting. I'm only paying for that exact time. I actually tested it and it was really, really good. This is one of the reasons I'm actually focused on Amazon here. Now, am I the only one actually seeing this as the Half-Life video game here? I couldn't stop playing it once I start seeing it, so kind of cool. Anyhow, I'm not trying to fool anybody here. I mean, there's some brilliant people here, probably smarter than me, the computer scientists. You need servers. But for our purpose, for our point of view, for this specific task, for presentation, for developing our apps, we don't care about them. Now, this is a security conference, so I actually indulge you. Go ahead and try, break out of the Lambda, find vulnerabilities. You can make good money if you find one from Amazon, for example, on their bug bounty, but leave it for now. Focus on just the way we develop our apps. So, it's not perfect though. It's pretty new, and there's some really cool limitations. Remember, we're using the scraps of whatever the cloud provider gives us. So first thing, there's a pretty steep learning curve, and I'm trying to break some of those barriers today. We are not owning the app. We are basically running it somewhere in the magical realm of the cloud. So first thing is that it's really hard to debug. I mean, it's not hard, it's different. For example, there's not much breakpoints or traces or hooks the way we used to debug our apps today. You need to work a lot of exceptions and login exceptions and things like that. So this is something really important to understand. Another thing is there are some technical limitations. For example, when Lambda just started, you had a limit of storage of 500 megabytes. Now that's pretty small. Now it's 2 gigabytes. But let's say you're dealing with some video app that needs to process or generates more than 2 gigabytes of storage, then probably serverless yet is not for you. There's also a limit. Remember, we're using the scraps. So we're using some kind of a server that is currently not fully optimized. So the main cloud providers have limited mostly to 15 minutes. You can't run a single function more than 15 minutes. Usually when I work with people who start working with it, when myself, if you get to something that runs more than 15 minutes, either you didn't properly optimize your code, or if you really need to with some like really magical machine learning algorithm or something like that, then you probably want to use Dockers or something else. But it's a limitation worth knowing. And the last thing is the concept of warm and cold boot. This is something really important. What basically happens in the background, for example, Amazon, they have their own containers, and you're creating a package, your code, you deploy it into their sphere, and then it's waiting for a trigger. Whenever the triggers start, they will shift your container to that location that wasn't really used and will execute. So you have 3 steps here. The container is starting to deploy, and then usually functions have some kind of initialization code. Let's say we're doing AV scanning. I want to get the latest signatures, so I'm going to download them. That takes a few seconds as well. And only then the first step of actually running your main function of whatever you wanted to do. So that takes a bit of time, usually a few seconds. But there's something cool. Because of the optimization, they're not going to deploy that package all the time. So there's a short time span. If you execute your function again, it means it's a warm boot now, and you're going to execute your function right away. So you can actually even abuse that if you want to keep your functions running all the time. So it's something really important to understand. But if you look at it, it also means that serverless is not feasible for everything. Let's say you deal with some police alerting or weather activity, tsunami alerts, and a few seconds actually really counts. So you might don't want to use that as well. But most, especially for research apps, it's well more than enough, this few seconds. Now, it all might sound like Hansel and Gretel stories. I'm Candyland, but remember, we are researchers, we work in a very hostile environment. So we're dealing with exploits, malware, a nation state, for God's sake, and we don't want to mess with them too much. We must understand some of the security considerations before jumping in. So the first thing is, and I see it all the time, people work really fast when they start working with serverless and they forget about securing their code. And remember, we don't need to patch, we don't need to do updates, we don't need to secure the infrastructure about our code. If it's damn vulnerable, it's damn vulnerable. And things like event data injection are so common, RCEs. Some people even connect the serverless to a database, so you get SQL injection and stuff like that. Remember the OWASP top 10, all the AppSec principles, work with them really hard. Don't keep your security development lifecycle if you do it in production. The next thing is in insecure storage. Remember, you got some containers floating in that magical realm, and if you have some things like password, API keys, any secrets, social ID numbers saved in the storage, not encrypted, then it means that if it gets compromised somehow, your code gets, and if someone worked with GDPR or anything like that, sometimes you can't even know where your code is actually in. So there's some services to work around it. Amazon have their secrets, means you get an API call based on permission for the Lambda, and then you get your code, you run it in memory, and you destroy it right away. So remember that as well. After that, we have permissions. Remember, people are used to work with multi-purpose apps. So when they first starting to work with single-purpose function, what they actually do is making many functions, giving them many permissions, and then they get compromised, and all their infrastructure get compromised. So it's something that you really need to understand. Work on single-purpose functions and the least privilege access that you can. Also, budget exhaustion, really new concept. If we get DDoS today on our apps, usually what it means that our services are going to be down. Maybe we're going to lose some. For research, usually it doesn't really mean much, but for production, means that we are going to lose money on not operating. It doesn't mean we're actually going to pay more money based on the usage. So for example, with Emotet, they actually attacked our services and they were trying to make us use more bandwidth. Remember, it's scalable. The cloud providers doesn't know it's an attack, and they just provide more and more resources to you. So you can actually, or sometimes it's errors that your programmers did. So remember to monitor and set up bad budgets according to what you can actually afford. Also verbose exceptions. People get hooked to how rapid they can actually develop code. But when you develop rapid code, people leave a lot of exceptions, a lot of verbose exceptions, and sometimes I've seen passwords being returned to the users because they really wanted to debug. So remember not doing that as well. And last thing, we are heavily relying on logging from the application side, from the infrastructure side. For example, if it's a web application, it's the Nginx. If it's other ones, then we're relying on those logs. With functions, those kind of functions, there is no logs in the infrastructure. You need to write the logs yourself. Record every activity, record every exception. Most of them have some building tools as well. So I really wanted to find an out of war quote, but I couldn't find one. And it's the keynotes. You must have one, and you guys are left with that. But anyhow, let's look at some more practical examples. Binary alert by Airbnb. Airbnb are heavily relying on Amazon, and I spoke to their security engineering because I really wanted to understand why they used it. So basically, they created a way to get alerts on every malicious file getting uploaded to Airbnb. Why they decided to use serverless is actually pretty unique. Because the engineering team didn't have approval to stop uploading files. What does it mean when you upload a file to Airbnb? It's a profile picture, new user, or new listing, some kind of a house listing. So it means if they stop it for 1 minute, they're going to lose a lot of money. So what they did, they actually created a way to trigger parallel to the actual logic of their apps. And whenever someone using S3 bucket is the storage unit for Amazon, someone upload a file, the app for Airbnb is uploading some kind of a file, it will go to a Lambda, trigger an event. The main Lambda has a dispatcher. It basically will connect to many other Lambdas, Yara analyzers, mostly Clam AVs, and whenever it finds a malicious, it will stream an alert. So basically going back to the Airbnb app and probably deleting the file or marking it as malicious. What's so cool about it? First, they can do whatever they want with the app. It doesn't affect the main business logic app. So they can do changes with it, they can play with it. Another thing is that they can add as many analyzers as they want, or if a simple analyzer is not going to work, the other analyzers will work. So they can play with it as much as they want. They can be experimental. The only thing they are really taking in consideration is the dispatcher. So whenever you actually add a function or an analyzer that work with it. And last thing, they really care about not doing false positive and stuff. But really cool project. It's completely open source, so have a look at it. Alright, another project called MailScanBot. Quick disclosure, this is something I built, so take it as you wish. But basically it's also open source. You can try it out on Telegram. It's a bot that helps people scan malware, work with some analysis from your mobile phone. The reason I created it was I'm traveling a lot. I'm in a lot of conferences. I usually don't have my laptop with me, and I have a really stupid iPhone that I can't do anything with other than messaging. So I actually created that bot. And basically what it is, you are uploading a file, you can play with it, you can submit URLs and stuff. But something really cool is that I completely build it over serverless. So I don't need to SSH to anything or work with anything in case something breaks. So basically the way it's designed, now there's not just Telegram, there's Facebook coming up, Slack and web. And basically I have one single API gateway by Amazon. It's like their version of web gateway, Nginx, also serverless. And every command that you've seen, like virus total scanning, things like that, will be traced back to a corresponding lambda. So for example, some file getting scanned, I'm scanning it, and then I'm replaying it was scanned. I'm also triggering actual scan in the background, so you can actually report back to it, etc. So pretty cool. Again, open source. Have a look at it if you want. Now, I wanted to take something. Anyone build a malware sinkhole before here? Cool. One. That's good. And basically, a malware sinkhole is where us researchers, threat analyzers, taking hostage or taking in control a domain as command and control center owned by attackers. We usually register the domain either by the help of law enforcement, or we find a way to register before them, or it was not registered, and then we subvert all the traffic of the malware to us. What's really problematic with it? Usually we have no idea the magnitude of the attack. We can simulate maybe, but usually we don't really know. And that makes it really challenging. Also, because this is something that extremely upset attackers. Every time I did that, I was under attack if they know who you are. So you really need to secure your infrastructure. You need to set it up differently, and it's not like your normal apps. So basically, serverless can actually solve that really fast, and it takes months to get a sinkhole up and running. So first thing I wanted to do is find a syncable malware. I don't know if it's a real world, but basically, and malware I can sync. Now, we didn't have a full database of malware for this specific demonstration, and I didn't randomly just found one. So I actually went ahead, looked a bit, and this is something you can use. Anyway, it's a doc, I can share it later, but it's a Google doc. You can look for NX domain, a tag in VirusTotal, and it basically means a malware was running and the IP was not resolved. You couldn't find an IP, so it may be a good candidate. I looked up and I found a couple of samples. This one specifically is an old SMIDA campaign. Some of you might be familiar with it. And when I checked with MailScanBot, I can see it not registered. I went to a cloud sandbox, AnyRun, ran it, and I see that it's still valid. And then I actually checked the IPs over here are other sinkholes. So it's kind of cool. Actually, okay, I have a good candidate. Registered it and went to Amazon again. I love it, sorry. And what I did is I took Amazon Route 53. It's the Amazon name server. Again, a service for domain name redirection, etc. But it has really cool, unique feature. Instead of redirecting to an IP or another domain, you can redirect to an S3 bucket to serve web files, static web files. And basically, I can also have, so I already have some kind of a website that's redirecting all of the queries, and then you can actually save all the access logs. So I have another bucket to save the access logs, and created a really quick Lambda with a combination to Elasticsearch. Now, all of that is just a simple next. You don't even need to be a programmer much. And I'm copying every log to the Elasticsearch service. So basically what happens, we redirect the traffic to us. We're already seeing some logs from the malware. And in less than an hour, I already have like a show-off graph. This is like a time to rapid show-off graph of all the heat maps of all the IPs around the world that are basically attacking us. So it's really shown. Took me, I think I calculated with breaks, maybe an hour and a half to get a malware, to analyze it, to create a full serverless sinkhole, and actually already have results. So I can actually, for example, the IP here in Israel belonged to a bank. And I sent it like after 2 hours and told them, hey guys, you got an infection. The main one in United Kingdom, you guys are not actually infected. This is Fortinet Sandbox. So they're analyzing that malware a lot. So just a couple examples. All right, so let's do a quick demo. Hopefully I said my prayers to the demo god and everything is working fine. Alright, so basically what you're seeing here, it's called Cloud9. It's a cloud browser only IDE by Amazon. Basically you can have your own environment set up and just use your browser, whatever computer you use, and you can write your code. Now it's not the best IDE, like if you work with Python, PyCharm might be better, but it has a really good integrations with all the cloud Amazon serverless functions. So what I'm going to do here, basically, we're going to build a really quick domain analyzer API, send some kind of a queries and get results back. So what I'm going to do first, I'm going to create a folder for our app. And because I'm working with Python 3.6 for this example, I'm going to create a virtual environment. Always work with virtual environments. If you don't, start with it now because it's going to save you a lot of problems. Alright, I'm inside my virtual environment and now I'm going to install a framework called Chalice. Chalice is basically a really getting started framework in Python. They do a lot of the backend for serverless for you to get started. I don't usually recommend it for production. We'll see why in a few minutes. But it's cool to get started, cool to get understanding what you can do with it and play with it a bit. The documentation is actually pretty well. So now I'm going to do Chalice, and internet stopped working. New project, and let's call it domain analyzer. That's good. I actually like the name. Alright, so I'm gonna cd into it, analyzer. And if we look at it, we basically, let's do an ls. We actually have app.py, that's our main app, and requirements. We're actually going to ignore the requirements, but for Lambda, it's really important. If you're using any kind of third-party prerequisites that are not coming built in with Lambda, you need to bring the actual binaries yourself. Really, really important. But for this demo, we're going to skip that because it does take a bit of time. So basically what we have here is a simple app. We import the main Chalice framework. We got some domain analyzer app. And we have the route. Route is really important. Basically telling the API gateway, this route, direct it to this function, the def here. So we have hello world, let's call it BSides Liverpool. Alright, now we're going to do is simple Chalice deploy. And what Chalice is doing now, it's setting up an IAM rule with only the permissions you need, kind of, and creating a new function called domain analyzer, and then basically deploying the code to it. Once it's deployed, allocating API gateway, that is every time the API gateway gets triggered, the Lambda gets triggered with the input you ever actually sent to it. So what we have here is an API URL, click on it, and hey, we have hello BSides Liverpool. Pretty simple right now, but remember, all of you can go to this link right now, it's going to work. Almost everybody in the world can go to this link right now, it will work, it will stay there, and you will only pay for those type of queries. So it's actually rather cool. Now, what I'm going to do is I'm going to just copy a bit to save some time, and we're going to go through this code. So first thing I do is I copy a couple of imports. If anyone worked with Python before, then socket, pretty standard, don't use it. Library that does network. Some bad requests and Python requests. Anyone work with Python on web, then it's a library you really, really want to use to work with web pages, etc., APIs. Alright, so we have that. And now what I'm going to do is copy a few simple definitions that are going to be the main code base for our API today. Everybody can see well the code and everything? Cool. So basically what we have here, for example, we're going to do NS lookup. We're going to give it a domain and we're going to get an IP in return. So something like that. NS lookup, and let's do BSides Liverpool. Alright, so we have BSides Liverpool. And look at it, this is the parameter we're actually taking. So we're taking straight any parameter given in the URL, and we're actually very badly giving it back to socket, get host by name. Don't do that. There's actually some vulnerabilities in here, but it's just a really simple example, and we're returning it back to the user with the domain they gave and the actual IP. Alright? Another thing we're going to do is, last year I did a talk about malicious crypto miners, and we've created a feed and an API. This is actually some of the way MailScanBot is also using it in the background. And basically an API, you can query a feed that's on GitHub that says, that lists most of the crypto miner domains and returns some kind of a message if it's in those feed or not. And the last thing, I'm pretty lazy, you probably know this by now, so I don't like to analyze a domain with just the IP and then the domain, the crypto miners and everything, so I created a kind of a mix of everything that I called analyze. Make sense? Cool. Now we're going to do, we saved, did I? And now I'm going to do again Charlie's deploy. So it's pretty cool. You can see how fast we can deploy apps really, really fast due to minor changes of the code. So what we have here is NSLOOKUP BSides Liverpool. And you see we already have some kind of a reply about the BSides Liverpool. Hopefully you are not in the coin blocker list. That's going to look bad if you do. No? Nice. And the last thing, basically, let's do analyze. And we got the answer. So again, we can make it more beautiful, anything, but remember, this is something you can actually use really, really fast. The cool thing about API Gateway and Lambda, there are some built-in protections. You can actually generate quotas. So if you want to give your friend only 100 queries a day, stuff like that, they will do it for you as well. And again, multinational, a lot of places, everything can use it. Very, very scalable. Alright, so last thing, because I don't want it to be overly abused, Charlie's delete. Alright. Alright, so just finishing up, quick recap. We went through some of the things, at least for myself, I found really, really challenging when I was building my research app and I was working with other teams, with other companies. We went through what is serverless, some introductions, things that they do better, some security considerations, common vulnerabilities, etc. We went through some usage of like binary alert, MailScanBot. We did a step-by-step how to build a sinkhole. Hopefully that was a bit of insight that you can build your own apps with it as well. And lastly, we did a quick demo using Charlie's how we can deploy a domain analyzer app. So thank you.